Check. Check. Alright, let's have a squiz at... What are we doing, David? We are...
Well, there's this this microscope stand.
Yep, this HDMI microscope I'm looking at stock in, but it's got a few problems and I'd like to add some tweaks. So, yeah, it falls over.
Yeah, so if you're using the touchscreen, which you have to,
yeah.
you knock the thing over.
So it's designed to...
This is the touchscreen one, or is this?
Yeah,
this is a button?
Oh, sorry, no, it's buttons.
Yeah.
So oh, God,
Buttons
hang
only.
on. No, now it's done up too tight. It does undo. There we go. Normally it's like that. That's how it's normally supplied. Now, I don't like the dinky lights, and I'll explain why. And, yeah, I don't like the base, because the base just gets in the way of shit. I want to be, you know, it's just, no, it's dinky. Even though it's visible area, even if you go right to the top, even if you go all the way to the top of the stand, it can go higher, by the way, it can focus higher, which I'd like to do, but it's not a showstopper. So even, like, the visible area is probably no bigger, it's not bigger than that stand, so it's actually quite small. So from that point of view, I guess that's why they designed it like that.
Is the color a benefit? So
colour?
because it's a light color, and if you put like a black IC on it,
Oh, it could, but
it stands out quite a lot. So if we were to redesign the base,
it could, but no, I don't want a base there. I want to be able to use the bench.
Yeah.
I think it's just bad. I just personally don't like it. So I want to flip it around like that. So no modification required. You just install it a different way. That's how it... There we go. That's how it works. You just install it a different way and bingo. But, there's always a but. The problem is that now for... Oh, sorry. Yeah, these things we have to like take off because they're... Look, we still don't have the weight, right? Now we have to stop it. They're falling over, right?
now the lights are
They're already supplied. Yeah, the whole idea was to design that because I want a LED ring. I don't like these dinky lights. Even though they are very flexible. Having them on the arms makes it flexible in terms of getting the angles for the light, but you're always dicking around with them. And I much prefer a good...
And two point sources cast two shadows as well, so...
Yeah, but it can, but then you can just have one going at a shallow angle. You know, it's versatile, but you only need it like 5% of the time. So 95% of the time it's useless. So the idea was to... What? Yeah, it's falling down because the thumb screw at the back's not done up. So...
Would that be a problem?
It could be if you have enough weight on it.
Yeah.
So, yeah, no, you just do that up, and that changes your friction inside the. It's got a. Is it a plastic thing? Yeah, it's a plastic. Plastic grub. I don't know what the name for that is.
It's a D-shaped piece of probably low density polyethylene.
Yep.
Or maybe Teflon.
Plastic.
It's a white plastic. That's what we can see.
And right, so that adjusts the friction on that. So I've got no real problem with that, unless you want to redesign the whole thing. So the idea was to have a ring light, because I wanted a ring light, and then I thought, well, if you're going to have it this way, you might as well have the batteries at the back, because I'd like to power it from batteries, although it can optionally have a DC jack on the back, of course.
Yeah.
But then if you're relying on the batteries for weight, tell people to put dead batteries in it and power it from the plug pack. I don't know. I've yet to do calculations on how much light is required versus the battery life and all. You know, if you're only going to get an hour's battery life, that's obviously pretty shitty. So, but at the moment...
Well,
what?
We can do that, I think.
Oh, there's no need to do that now. I don't think. We can make them use D cells. Put two big D cells on there. And,
well, that'll be enough.
Yeah.
The D cells over here, right?
I've probably got some D cells. Yeah, I've got some D cells in there. Yep, we can get the weight difference between D cells and see, but that's... Hang on. So, there's your problem.
I'll cut those off.
Cut what off?
These.
Oh,
Put the D cell in.
Yep. we could look this up on a data sheet, but you know, a D cell weighs 135 grams.
Versus?
Oh, well, this is not an alkaline, but it's near enough. It's rechargeable. 26 grams. So, yeah, it's like 5 times. Right? 4 or 5 times the weight. So, whoa, there we go.
That was inevitable.
Yep. But if you had, I mean, D cells are huge. I mean, look at the, like, you wouldn't have to worry about that.
No.
Maybe tape it. Just, oh yeah, there we go. Ah, clever, clever man. All right. So that is gonna fall. Yeah, even when you have them as close as you can get them, wham! That really does the business, doesn't it?
Yeah.
Does it look rinky-dinky? No. If we had a board with battery mount D cells,
There is a thing about like the top heaviness of the whole thing. So like.
right? Yeah.
It's okay on this actually. It's oh, past that point it's not. But that's
Right,
that's a big push.
Yeah, but you shouldn't have to. You know, you should. Yeah.
Yeah.
I mean, as long as you can operate the thing. Actually, that makes it feel a bit more rigid. Before, it really felt rinky-dinky.
Yeah.
Dodgy.
Does this whole stand come off? I'm curious. From the
Uh,
bottom.
yes, I believe. Yeah, it comes. Yes, because it came in a small flat box, and you assembled it.
Yeah.
Assembled the pieces. Yeah. So,
Okay.
no, yeah, this comes. Yeah, this unscrews from here.
Because this bit, because if you take these off, then you're left with these 2 holes, right?
Yeah. If we take the leads off, that is my camera talking to me.
I thought I was like hallucinating.
Yeah,
You didn't react at all. I'm like, man, I'm hearing things.
Yep. No, it's. Yeah. There, see, the whole thing screws out of the base. Right? Okay. So that will.
Take that out.
Yeah, you want to take it all off?
Yeah.
Yeah, there we go.
Okay.
All right.
Let's see if this is.
So this is how it's supplied. Yeah, so it's assembled yourself. So obviously,
That's quite a useful. That's
what?
That opens up some flexibility. It's a standard tapped hole. It's not like this profile isn't in this. So.
Yeah.
If you wanted to do the light ring, and then. As well.
What, redo the base?
Yeah, because it's just a rectangle anodized.
Right, you can specify it tapped. Okay, so you can get your own.
Yeah, it's very simple.
Right.
Like.
Yeah. Okay.
Yeah. Because that way you can not have these spare holes.
See, that's the thing, right? You buy the camera. You can just buy the camera. I'm pretty sure they'll just sell me the camera.
Yeah.
I think you can even buy it just the camera commercially. So,
It's a very nice camera.
it's until you look inside and see the hot melt that they've glued the lens on with. But it works.
Apparently,
works.
whatever.
Yeah, it works, and the software is pretty dodgy in it, but it works, right? And it's really quite good, especially for the price and the working range you get with it. The working distance is the killer. It's really 150, 200 millimeters working distance.
Great.
It's pretty good.
Is this lens? It's not flush. Good.
Okay, so there is some.
Yeah, I'm not
Yeah,
putting
it
the
is
lens straight on
actually
the table.
recessed.
Yeah.
Oh, actually, that comes off.
I wonder if you could use that to attach the light ring.
You could, but the
that's
whole
that's just a clear glass thing. It's not a lens, right?
No, yeah, but you don't want that weight on that. So it's better to. I mean, we've already got this support here, and that's not very zoomed in, is it? I don't know when or if we'll release this video. It's one of those. Yeah, you got to tilt the screen. Just zooming in until we're more in frame, I guess.
Is this a rotation one?
No, it just.
I don't know how to use your tripod. I'm really confused.
It's just side to side. It's just rotate side to side.
Does it go up and down?
It should. The thing on the side that loosens it.
How's that?
Oh yeah, if you're yep. Did you tighten the thing back up?
Probably not.
I don't remember.
Noob. Yep. All right. Yay, we're in.
Yep, it's all right.
All right. So, yeah, so you can just buy the camera, but they do sell everything, you know. Although I'm sure, I have not spoken to them about this, but I'm sure that they'll just sell us this bit if we wanted it. They'd probably just sell us this bit. So if we wanted to do our own base, we could. I can't see any reason to redo the ratchet mechanism. Can you? I know there's always a way to improve it, but you don't want to
Just thinking.
gild the lily and do too much. Like if they've
That is my thing.
yeah, I know, and
So when you say is there a reason, I'm like, oh, well,
yeah,
the reflections from the silver from the light ring will
no,
make little
No.
focus points. 'Cause
no,
you got
no,
this.
no.
But other than, so I was thinking black.
Forget about it. No, well, no, that's it's going to be a non-issue. I can guarantee you, it's going to be a non-issue. Reflection
What's
off
that? What's that fashionable material now? The Vanta black or whatever. It's like the blackest material on the planet.
Oh, okay, right,
Yeah, it's last year they had one. They released a new one this year.
right.
It's so black that you can put an object here and an object way back there, and you
Right.
can't tell the difference between where they are.
So it's a near perfect
Yeah.
black body source. You can
Yeah.
use those for thermal.
Yeah, it's like a tight
Is
cluster.
it thermally conductive?
I don't know, but it's well, I would assume it has to be.
Alright.
It's a tight cluster of carbon nanotubes,
Oh, okay. Right. Oh, right. Okay. Yep.
something
it.
like that. Yeah.
Got it. All right. Now, yeah, these lights, they're kind of useful, but ultimately, I think they're more annoying than not.
Yeah, like
Yeah, and you're always dicking around. Whereas a good ring light will do 95% of your work, 99% of your work,
in 50% less time.
and then if you want to get, and if you with no zero hassle,
yeah.
and then if you want to get the pin numbers with a certain angle, you just tilt your board. Like that's what
It's
I do
got the
under
height.
the Mantis. Yeah, that's what they do under the Mantis.
It's got the height anyway.
It's got the height anyway, exactly.
Yeah.
So, and the other thing is they've done these really horribly. They've got like a control on it.
Yeah, this is no good.
And look, and the cabling is all dodgy, brothers. Right? It's just it's garbage. They've got like we're missing. Oh no, here it is. They've got this metal thing which then goes on here, and it's all dodgy.
I guess that's the only reason for redesign here. Like, in terms of aesthetics, like
Yes, it does not come with these, by the way. We're just using
it
these.
doesn't look very like refined. the
No,
design.
it doesn't. No, it doesn't
And
look
I did
professional,
notice
but
this-
it's a cheap price, right? It's a $200 microscope,
That's true.
right?
But all this can be like they've done it for this price.
Yeah.
Adding bevels isn't going to really change it all that much.
No.
Making it they've used just a
Yeah,
silver.
but then it's just another thing to engineer, right?
Yeah, mechanical parts are pretty low risk though, unless you're doing huge quantities where you have to set up your own line.
Yeah, but no, look, but they can supply this already done, no hassle. End of project, right? As far as mechanical. If you wanted to do another base, I'd understand it because they would have to do a custom base anyway. Otherwise, going to end up with two holes here
Yes.
for these LEDs, right?
Yep.
So you might as well do a custom base.
Yeah.
And
custom base.
that's as trivial. Even I can design a custom base
Yeah.
for this, right?
Yeah.
That's not even aluminium. What is that?
Let me see.
Some sort of zinc alloy?
Oh, and it's probably the anodizing. I don't know.
No, yeah, you think it's so you think
Are
it's
you against me scratching
aluminium? No, I don't care. Okay, so you think it's aluminium with
pretty
some
hard.
dinky anodizing.
Yeah.
Right. Anyway, it just feels.
Yeah, I thought it might have been like an aluminium paint.
Oh, okay, right. Okay.
It's kind of like, but that's the machining marks.
Got it.
Yeah.
Anyway, the good thing about this is that A, it's already done. B, it's adequate. It's not, let's just say, the quality's not the best. All right? But it's adequate for the price.
Yeah.
And,
Maybe add a big thumb wheel at the back. That's the only real thing
oh,
that's
well,
bothering me.
Okay.
A
right.
big one.
A big one?
Yeah.
I wouldn't say no to that.
Yeah.
But the problem is you
or
can't
like a
make it
butterfly one or
too much bigger because then your board's in the way. Right?
It's true.
So the board,
You wouldn't want the board.
because the board's coming. Oh, no. I'm going to do what I'm going to do here. There can be a cutout in the board. There can be a slot
Yeah,
in the
because
board.
otherwise you'll get in the way of it too much.
Yeah. And a slot.
It's got to come around like a fair bit.
That's what I wanted to do for these thumb screws here as well, which tighten up the scope. I don't necessarily like these. I think these are a bit dinky too. but you only have to set them once.
Yeah.
Right, and I was going to put slots in the board so that you could get your, your fingers in there.
Sounds good.
Yeah. Well, actually, the ring might come out like a large way out like this, like because there's no weight on the end of the ring, so there's no reason the PCB has to sit on there or anything like that. It can just come out, and the ring can be like have a huge gap that you can get your entire
ideally
I would do that.
like,
Yeah,
isn't
like
wider better?
Wider is better because
Yeah.
you get so it'd be like a wide ring like this. You know? Yeah, and so
To a point.
gets a bit silly, but yeah, wider the better. So the ring is probably going to be like 100 mil diameter, something like that, all right?
Yeah.
And the leads will be out here, and they'll be on a strip. So anyway, so we have got this flat base in here to support the board. Obviously, no conductive traces on the bottom.
And no, there's no mounting screws at the moment.
No, there's no mounting screws.
So
There's a hole through there. There's a big slot.
Get rid of the tape.
There you go. There's a big slot. Electrical tape. There you go. There's a big slot in there. I was gonna say that we just get a big like a bolt and a washer, and it just bolts. Have a hole in the board, and it just bolts in.
Plastic insert.
I wouldn't even go that far. No, I'd just have a bolt, a hex bolt with a nut on the bottom. Done.
It'll work.
Yeah. So the board lays flat like that, comes out, and then sticks out the back like this.
The thing about if it goes back far,
Yep.
the springiness of the PCB.
There's the springiness of the PCB,
Which
but
one?
1.6 millimeters is going to still do all right.
Do we have a long PCB?
No, I've got it. Yeah, I've got a. Oh no, it's at home. I've got like a PCB ruler that's 1.6 millimeters.
Oh, we can put two of yours together.
Right. No, mine are 0.5. Oh no, some of mine are 0.8s. Yeah.
Oh gosh, that's uncomfortable. Alright, that's pretty long. Good.
Although that's not a good test because then it's not a cohesively glue. Well, we can actually glue them. You know.
You can tape them the whole way.
You know, no, these are your 0.5s.
Oh shoot.
Yeah.
Well, three of them.
Three. Give me three. Yeah.
It's close enough. The tolerance of the PCBs isn't that great. Thickness, is it?
No, that's no. These are more flexible than a single 1.6.
Yeah, they definitely are.
Yeah.
That's not.
Yep.
Yeah, that's easily more flexible.
So, two D cells might be. You're right. It might be a bit too much weight, but
Like
well, we can actually. That's the least of our worries. I think you can always get a 2 millimeter board. You can say let's get a 2 millimeter board.
That's true.
Or a 2.4. It's not going to cost a huge amount extra in the scheme of things.
yeah.
So
there's still the option of like redoing this bit and having a supporting.
you could redo this. This is in two parts. This has screws.
Yeah. So leave this and this, but
Right.
change this because there's no.
Yeah, but this requires tight tolerance, so you might not get it on the first. They've already designed it. I wouldn't bother. I wouldn't. I just think the less things we have to design, just the faster. The faster we're going to do it. And,
Yeah.
Well, you can always reserve the right to change this later, right?
It's true.
I would design your board first around the fact that you'll keep it, and if you change it, it doesn't make a difference.
You just add a screw hole or something.
Yeah, it doesn't.
Yeah.
It doesn't really make a difference.
It's true. Yeah.
Yeah, so I would just do it, and then
That definitely
If
has
we
to be
need to-
bigger.
what?
This screw thing. You can't
Yeah,
tighten
yeah,
it to a point where
yeah,
there's
the
this
thumb screw. Yeah.
Yeah.
So we'll get a bigger thumb screw, and then we'll just have a slot. Yeah, in the board.
Yeah.
Yeah. Well, that's easy to engineer, right?
Yeah.
That thumb screw. No worries. All right, we can do that. All right. So
Does it work? Oh, my old phone used to do that.
there's almost nothing for you to do from a mechanical point of view, is there?
Yeah, the base, I guess. That's about it. I can give you a bit of a tiny bit of forward, and you get substantial improved performance.
Oh,
You
like
get-
a little round 40.
Only a little bit.
Just a little, just like a centimetre maybe.
You get heaps of better
Yeah.
because this is where effective edge is. Like, it's not actually there. You just need a little bit,
Can
and
we
you might
make
be,
it shaped like something funky?
Yeah.
Can we do I don't know, the bat symbol, or make it make it like I don't know, the Starship Enterprise? I don't know.
Yeah, that's all fine.
Yeah. Okay.
Yeah.
Okay. So redo the base.
Yeah, as long
make
as
it
it's
funky.
Not, as long as it's not like contoured in a way that requires special machining processes.
Oh no. It'll just be flat like this. Not even the edges don't even need to be beveled. No.
They should be.
Whatever.
Because then when you anodize it,
Or tumbled or whatever they are. I don't know.
yeah.
Anyway.
This is sandblasted then anodized.
Yep. All right, yeah, so we can do that, and then just have it. You are right. If we come forward from the pivot point,
you can even just,
by a centimeter,
just halfway.
Oh, you wouldn't even need to go halfway.
The radius would be quite large.
You wouldn't even. Yeah. Oh, okay. Well, depends how far out you want to go.
Well, you can go as far like
yeah, but
effectively.
The problem is most boards you're going to put under here are square.
Yeah.
Right?
So if it's something like this. There you go. It's going to be okay with even enormous boards.
Look, even if you come out like that.
Even if someone decided to put a DeLorean in there.
Right. Even if you came out a centimetre, because the problem with this, right, is that the feet...
It actually comes out a centimetre. It just...
feet... Yeah, the problem with this is that the stick-on feet are in line with 10. The axes of this.
Yeah, it's effective as 10 back.
Yeah, so if you could actually put extended feet on this, and it'd probably stop it falling over. So we probably wouldn't even need the weight of the D cells.
No, maybe not. We can do an adjustable jig and figure out where it needs to go. Hacky little thing.
Yep. Although
a bit of plywood and just keep taking more off.
Right.
Yeah.
Just sand a bit more off.
Yeah, that's probably the best way.
So new base. We'll do that ourselves.
Although the plywood's the wrong weight. And it makes a big difference because of this.
Yep.
Yeah.
So, just a rubber feet. I'm happy with just stick-on rubber feet.
Cool.
Nothing fancy required there. No, just a flat plate because it's cheap and easy to get a flat aluminium plate machine.
Yeah, and we don't actually need all this distance anymore. Because the only section that really supports it is the front.
Yes. Yes, correct.
Although you do have the weight of it assisting. So I don't know.
So you don't see anything wrong with this because they've already supplied all this.
What is this screw thing?
And I'm not talking fussy. I'm just talking is there a showstopper problem?
This is tightened.
It's a little bit rinky-dinky as you move it up and down. It gets better with the more weight you put on it. When we had the batteries on before, it felt stronger. It felt better, it felt more solid.
Yeah. You want it to have a constant torque a little bit, constant friction. Yeah,
well, that's what the plastic plug in there does, and you can't do much better than that plastic plug without going really...
Plastic plug plus spring, so it's got a minimum amount of friction, and then that stops it from jiggling. Not
on a scope of this price. No. If you were doing a $10,000 Leica, you'd go to town.
No, I don't see anything, no showstoppers.
All right, but we do need a bigger wheel, right?
Yeah, because that one's...
These wheels here are probably good enough, right?
Yeah, they're good size.
Yep. All right. So if we stick with that, these are a bit small and dinky, but as we said, we might want to machine these are a bit bigger too. But these are set and forget. So
could even be Allen if they're set and forget.
Oh right, yeah,
permanent.
could be. And I know that you wanted this anodized.
Black.
You thought this looked pretty ratty.
Which part?
This the focus.
I like the gold. I think it's okay. I just don't like these two. The silver and gold.
Yeah, right.
It looks dodgy.
It does look a bit,
If
because
we
they're
get
different.
This black,
yes, you're
then
right.
that'll work.
Yep. Yep.
Or if we can get this the gold, then that'll work.
You're right. I can ask them. I'll ask them about that. Yeah.
They should have matched that.
I know. But no, obviously what they've done is they've designed this first, and somebody else designed this, and they just didn't care. Which is fair enough, it's a, it's a $200 microscope, right?
Yeah, they're going for quick and
dirty, to get something on the market. Now they're putting a lot of work into getting the optics right, getting the performance right out of the thing.
Which for us utilitarians is all that should matter.
It should, which is why I like this.
Yeah.
Because I'll show you. You haven't seen this working, have you?
Yeah, I have.
Oh, you have?
Yeah.
Okay, right.
Yeah.
Yeah, and the thing is, I think it can go higher. Because the actual field of view of this is quite small. Even at this maximum thing, I think the field of view... Did I measure
Do you
it?
want to turn it on now? Does it have battery?
No, I don't think it does have battery. I think you have to power it.
Hold on.
Yeah.
Micro USB?
That's something I don't know. You know? You got a power pack? I've got
Yep.
a power pack. Oh, sweet. What power pack you got?
One of these
Signet.
weird ones. Sold in JB.
No, there's no internal battery. I have not figured out how to get the video working. It's got video recording, it's got a microphone. Have not figured out how to do it yet. Didn't come with a manual, or it may have, but I might have tossed it. So, oops. I might have to ask him for a manual. I haven't figured it out though, which is ridiculous.
Yeah.
So let's put it back on here so that we can.
Oh well, if we figure out how high it can go,
Yep.
just
Right.
then that kind of says whether it's worth redoing that stand bit.
Right. Well, I can ask them because obviously they're getting this made and they're chopping it off. So I can ask them
Well,
just to make it longer.
It's not. Oh, there's a process of cutting.
Yeah.
Gear cutting. What's it
Right.
called? Hobbit. No, hobbing is a different thing. Gear hobbing sounds right.
I've kind of heard of that, but I don't know
But
what
it
it is.
stops at the top and the bottom, so it's not just
Oh, right.
it's not just cutting.
Oh yes, you're right. Okay, yeah. The teeth don't extend all the way to the top.
Damn it! It's
You
a
are
mini.
Mhm.
It's a mini USB.
Here we go. I have one here. No,
Got one.
got one.
Well, this box does.
We got one.
This box
How
is-
convenient was that? You didn't even have to get off your chair.
I did almost fall.
It's all right. We have OH&S insurance. Or whatever it is. It's all right. You're covered for workers' comp.
It's alright, I would have fallen on a
Is-
soft pile of wire.
This is a professional business here at the EV blog. All right. All right.
Alright.
Yep. Welcome. The dodgy font on there is just hilarious. All right. Now,
Yeah, so we need the field of view,
Hang
don't
on. Here we go. Yep. That's why you have a ruler. All right. That is inches. Give me millimeters. Okay. That field of view is 35 millimeters. Yeah.
And that's at approximately 170.
35. Okay, 35 millimeters field of view at 170.
Yep.
And that's actually it's probably all right. I'm probably being a bit fanny fuzzbot there. All right.
Still.
How? Hang on, I'm taking the protective film off.
Oh, that's been bothering me forever. I thought you were one of
Yeah.
those people who leave them on forever.
All right, no, hang on. The problem is, the lens has got a huge thumbprint on it, like really bad
I
thumbprint.
have some microfiber.
Yeah, I got some over there. I just couldn't be bothered getting up.
There you go.
Ah. Yeah,
Clean my phone screen.
that worked a treat. But nice bag.
Thanks.
I do appreciate a good bag.
Yeah, I've been throwing them away and getting new ones for ages.
Okay, you agree that's still in focus?
Easily.
It's better with a bigger screen, but now we're up to 40 millimeters and we're still in focus, okay? So let's just, yeah, there we go. Oh, I was going to do both. Whatever.
Me too.
Yeah. Okay. Now we're getting serious height. Like this is just ridiculous. It can focus. That's 50 millimeters.
I mean, if we go much higher, it's worth taking this stand out further.
I was going to say we're going up much higher, it gets,
It's still useful.
It's no, you're right. But going up that high, there's no point having
too
that
close.
same. It's too close.
Way too
It's
close.
too. Oh,
That-
what happened?
I don't know. It's still on. I think it went to sleep.
Hello. There we go. It did go to sleep. All right. We can still focus. You see how good that is? Now we're up to 60.
I don't think you'd go much higher than that.
You would know. That's just a ridiculous amount. But yeah, so you can imagine that blowing up on a big screen. We can do that later.
But for sake of like, how high does it go? I just want to see if you even need to think about the height when you build a stand height.
Oh, now it's really dark, but son of a bitch, it's still focusing at 80 millimeters field of view.
At like 40 centimeters.
Wow. Wow, yeah, that's a good 40 centimeters, isn't it?
Yeah.
Wow.
Let's see how close I was. 30. Are these right end? 30.
No, they're about 18 centimeters. Oh, sorry, 175.
Oh.
They're 175 a go.
350.
Weren't far off.
Ah, I was 4 millimeters off. No, it wasn't. The lens is there. Oh, yeah.
Oh. It's dark because we're all in shadow here, but that is sweet.
And your light ring will, like, you got no lights. Wait. I'm an idiot.
Oh,
So.
good. There you go.
Yeah, it's good.
Yeah, that's in focus, yeah. So you can take this almost to like that's arbitrary height. I mean, that's like...
It's probably got an infinite focal length.
Yeah,
or something.
yeah. It's crazy. Okay, so... Right.
Okay.
All right. So, right. We know there's no limit to how high you can take it.
Yeah.
All right.
Practically.
Practical. Engineers are by default. You can insert practically after everything. Like it's
true.
like I think it's the default stance of the engineer.
Have a sciencey little brother, which is the other default stance, I think.
Right. Yes. Exactly. No, engineer by default. Engineer is practical application, and it's the definition.
Yeah.
So awesome.
Cool.
We have.
Okay, so
That is
that's
cool.
That's that. So I'll design a stand, maybe like
Come out a little bit.
like maybe halfway or something like that, because then you're not getting interference at all.
Now they've got this. This is 2 pieces.
That's interesting.
It is interesting. Do we want to take it out further?
It is annoying.
It is annoyingly close, isn't it?
Not because it's
No, yeah,
like in the way.
Yeah.
It's just like,
Because if you want to put a board, you have to be at the top side of your board.
which means it's physically impossible to see certain boards.
Now, see, here's the problem.
Like I could never focus
No,
right here.
hang on. Here, yeah, I know. No, you can't.
Yeah.
Here's the, I think that needs to be fixed, actually. So here's the problem. You get to the point where, well, you might as well make that adjustable too.
Well, if it's
Right.
farther, like the further out's always better. Like you can always use
Yes,
something further
you
out.
can always use it
See,
further out.
There's no
Yep,
no
it's
benefit
fixed.
for having it go back and forth.
Like my Tagano. My Tagano is out by 30 centimetres. The arm comes across and then you can put, because there's a limit to how much big stuff you're going to put under. An average, like an A4 board, like an A4 is probably the biggest you're going to make.
Yeah.
Right?
Yeah. Or,
Practically.
Watch the big panels.
Oh, no, the big panels are huge, right? They're 16 inches by 24 or something, right?
Yeah.
But
Why?
you can't cater for that, right?
That'd be V-grooved anyway.
Yeah. No, I would say A4. If you could fit an A4 sized thing under there and get to the middle of an A4.
Yeah, so that's 297.
So you can always
right? So like,
Yep.
150.
Yeah,
That's what we need.
you can't make it infinitely. Like, people will have to engineer their own boom arms if they want
It
to do that.
needs to be
right?
that far for an A4.
Right. Can we simply provide different version of the lengths of these and assemble yourself?
Yeah. Yeah, this is heaps simple. There's no threading. Single slot. That is a squared slot. Oh, it doesn't have to be.
I have not taken that apart, so I don't...
Let's do it. Wait, okay. This.
Oh, right, okay. That does not come out. Because it's the teeth.
Maybe counter rotate? Do they? No.
They don't... How do they come out? Wow.
It might have been pressed in.
Oh, hang on. No. There's a cap. There's a cap. Look, it's got a cap.
Okay, tell me what it is. I'll get the thing.
It is a nut.
Damn it.
So the other side must be...
True.
I'll get both.
See, you don't want to be engineering this yourself. Like, you know, there's just so many, like...
Which part?
Ah, yeah, they're both nuts. Yeah. Yeah, there's a nut either side. So it's got a shaft through with a nut either side.
I see.
Yeah, it's a...
Oh, damn it. Alright.
Just give me a long pair of long nose pliers. Long nose pliers.
Just in case. I bought 3. They're all different.
I just destroyed our caps. Anyway.
Like, this part isn't actually all that complicated. Like, I'm going to bet it is a hollow section, no
Oh,
threading.
yeah. No. Yeah. Yep.
No internal routing. And the way they've designed it is almost...
Oh, they put thread locker on that?
One of them could be backwards, because if it's a single continuous...
Right.
Actually, no, it can't.
No, yeah. Wow, that's... they could have thread locker... Is that glue? Have they glued that in?
I don't know.
You haven't lost the plastic plug, have you? What is that?
What? No. Oh well, that works too. No, it's not coming out. That's weird. See how there's like a bit of spare shaft?
Yeah. Yes,
I was
there
hoping
is.
that it would, you know,
right,
pop
yeah.
in, but
Well, there's a bit of play in it, but not a huge amount. So how do they get these screws? These must be screwed on first before they assemble these.
it's just fun.
Right.
It's just a
So this is not a do-it-yourself thing.
like a press fit thing.
Yeah, this is not a...
What's that cap gone? I love the plastic. Oh, we can find out what kind of plastic this is.
It's probably a Delrin.
Yeah, self-lubricating material. Although it is lubricated with...
Yeah, it's got a bit
Some
of lube.
grease.
Okay, it's got a bit of lube on it. All right.
Yeah, it's greased. It feels polyethylene.
Okay. Anyway,
Could be Delrin. I don't know.
that's,
They did
that's
tap
kind of
it.
satisfying.
They did tap it,
Right.
so Delrin's one of the materials you can do that with.
Yep. I am a bit of a Delrin fanboy.
Me too. It's great.
It's a trademark, isn't it, Delrin?
Yeah, it's also called acetyl, also called...
Yeah.
It's a formaldehyde. It's like based on
Yeah,
formaldehyde.
I think you might be right. I was working with that 20 years ago.
Yeah, it's great. It's like you can use it on a mill and just keep using it.
Yeah, right.
Unless you have the mill set at the wrong thing, where you started off with a shit bit. But it doesn't like...
Yep.
It doesn't seem to dull the end mill.
All
very
right,
quickly.
so I'm sure we can get this apart. We don't have to necessarily worry about it now, do we?
Well, it depends. If you want to bring this out, then you can do all this in one section. Unless you want to have this as a separate part to that, which is fine.
Well, I would keep it a separate part because they've already engineered this part, and there's nothing wrong with it.
I think we can pull those screws out at an angle.
Yeah, might be able to give us a Phillips number. Yeah.
I'm trying to look for one with it.
Oh no, can't.
No. Thing getting in the way?
Yeah, can't do it.
This one. It doesn't have a
No.
PSD guard. It makes
No.
it thinner.
No. It's the It's the knob.
Oh,
It's the knob. No.
bummer.
I'll just strip that. So.
Well, that makes things that makes it more complicated.
Okay, so if they're supplying the shaft and they're supplying the, what's it called? Does it have a name? Does that have an engineering name?
I don't
The
know.
thing that goes
Housing.
onto
Everything's housing.
the block. I just call it the block.
Yeah. Okay.
The sliding block.
Yeah.
Right? So the sliding block, they will supply that. It's got some screw. Why can't it just come out a bit more? Like, so that you could access the screws with this off. Like, that'd be so much better. Maybe I could ask them to redesign it. Because that's the easy
Like, I
part.
can redesign.
Just get them
if,
to do.
if they want a free design,
Right.
like I can do it for them. And
No. I want to sell this exclusively. So.
Okay, but I can still.
Oh, but
we
if
can,
I
we can
get
still
them to
it.
do it, but yeah.
Still do it
anyway.
for them and ensure
Yeah,
they
and
have all
then-
the bevels.
and
We
then
can
say,
specify the
right.
anodizing to match, and make them Allen keys because
Yeah, I still like.
better.
it's not a project worthy of gilding the lily. I don't think. I think I just wanted to add a lead ring, and have the thing backwards. That's it. You know, end of story. I don't want to make the world's most perfect microscope because it's not. Like it never will be. So.
It's true. It's true.
But I think you're right. I think we need to extend this out because that is one of the downfalls of this is that it's too. Like it's designed to work on small stuff. But if we're up here. And we've got, what did we say? Standard was 35 millimeters.
Well, your biggest board is there to there. Like, center of the lens to there, right?
Huh?
If you're going to use
This is the biggest field of view.
The biggest board you can ever look at is...
35 millimeters across from that center. Oh, actually, that was across. That was a 16.9.
I'm talking about if you were to look at the middle of the board. You physically couldn't because the stand's in the way.
No,
So the biggest board you can ever look at the entire thing is 11 centimeters.
11 centimeters?
Yeah, to the middle because you can always rotate.
Oh, 60. Okay, yes, of course.
Yeah.
Right.
11 centimeters, 110 millimeters. Weird urge to knock over batteries.
You freak. Some people just want to watch the world burn. You're one of those, aren't you?
All batteries shall fall.
Die. All right.
All right. So stand, ring, stand, base, ring,
Stand.
extender.
Huh? Stand. A stand base. You
Stand.
2 words, 1 product.
Sorry, I had a bit
Stand
of
base. Yeah.
an aneurysm in the middle
Right.
there. Stand.
The base. Just say base.
Yeah, the base.
Base.
Extender. Ring.
Extender. But then, if we can't get them to, they're going to supply it with this,
Yeah.
with everything assembled, right?
Yeah.
With this assembled on here, and you kind of want that. You don't want people dicking around with these wheels and putting stickers on and like.
I can like if you, in terms of gilding the lily, just for completeness, this stand is completely redundant. Its complexity, like you could have a cylinder, plain cylinder,
Cylinder.
Linear bearing, round, threaded rod behind, put the raising thing at the top. And that keeps the raising thing out of the way of the PCB screw thing. It means that your 2 simpler parts...
So hang on.
And it's always much more secure. You don't have any of this jiggling.
So solid round shaft.
Yep.
A linear bearing that fits it. You can buy linear bearings, right?
Yep,
It just slides over. Does it have to be like a... No, it's just a loose-ish fit.
Oh no, they're pretty tight. But it doesn't matter. They're almost frictionless. Like.
Oh, sorry. Yeah, no, it's got to be anchored, doesn't it? So it's got to be.
Yeah, and then you have a trapezoidal screw, or for the US, the Acme ones.
So a screw that turns with a
yeah
handle on top.
And a top cap, which would stop it going up too far anyway. It's and that's,
so now he's saying re-engineer the whole lot.
Except,
this is where he wanted to go, folks. This is where he wanted to go. Nerd.
Well, whenever I see little things, inconsistencies in design, I go straight to
well, see, that's the problem. That's the feature creep problem you get when you look at problems like this. You go, oh, just one step further, and then
it does solve.
And then and then it starts solving issues.
It solves that.
Well, yes, it does. It would not fall under its own weight.
Yeah.
It would never fall under its own weight.
Yeah.
Correct. You are correct.
That's kind of what I was thinking, like, because the batteries, like, and I think we would struggle to tighten it enough to stop that.
Right. No, we did before. We had the batteries on there.
We should put it back, shouldn't we?
Yeah.
It's there. Up. Up. I forgot it. It's just. Yep. Here we go. And that way you need no locking mechanism, which means you don't need to have your PCB wrap around it. And you don't need this. You only got one wheel instead. And it can be one really high quality wheel for the same cost because you got 3.
There's no problem with the weight.
It's true. Let's see if it... No, it's fine.
But here's the problem, yeah, like, but then you got to re-engineer everything, right? But it's a shaft with a tapped end, right? So the tapped end...
Either way.
Yeah, right. So the shaft with the tapped end goes into the base,
yeah,
right? And then I don't understand how the shaft, this worm screw thing, what's it called?
Well, it's called a lead screw.
Lead screw, that's it.
And we're not looking, for people watching, it's not a ball screw. They would still fall by themselves. They're so low friction that it would still fall. Like my 3D printer did with the platform. But in the case of the 3D printer, you want it to always reset to the base. Or reset to a known position. So you want it to fall. But
hang on. What if you had flat base, like your printer, then a thing coming up and some scissor.
Oh yeah, Saris.
Some scissor, like a Saris thing.
Yeah. That's cool.
Oh, but this is just, no, see, this is where it just, like, we've gone from a solution which just needs a PCB and, like, an extra base which costs nothing to engineering the whole
But it still
solution.
costs just about nothing. There's some time costs, but, like, that's 2 days of design work.
Yeah, but the Saris one needs 3 sides, right?
Yeah, there's 2.
2, yes, you're correct.
It needs
but
2
then
sides.
I don't like unsymmetrical.
Yeah,
What's the correct term? I want to use the word asymmetrical. Asymmetrical, thank you. Asymmetrical. I like symmetry in things. So if we've got one platform like this and then another one over here and just one, yes, that's all you need to support it, but then it looks...
Yeah, it would still be like
It's not symmetrical.
I don't like the cylindrical thing, but it's a lot more cost effective having just one cylinder, linear bearing, one lead screw.
Okay, well, how does the lead screw? Does that need another hole in the bottom?
Yes.
Right, so it needs a hole in the bottom, so it sits there.
Yeah, and a plastic insert.
To stop it rubbing on the metal.
Yeah.
Right. So it needs a plastic insert.
Or a bearing.
Right. No, why would you use a bearing? No.
Oh, because it does support the weight of the thing.
Oh, okay.
So,
right, of course.
Yeah.
Oh, of course,
all
it does.
translate
Right,
into that
yes.
point.
All forces do translate into that plastic
Apart
ring in
from,
there.
this is the good part, this one, which is all through the
of course.
bearing. So,
yeah.
And then you have one top cap, and this one definitely just a plastic insert. You're not putting almost any force in it. And then you screw on the thing, lock from the end, so it's a thread inside the thread.
Hang on.
And then that's it.
So this top part needs something to come out, also with a hole in it, to keep the lead screw.
That's right.
in
It
place.
replaces this whole housing assembly. So.
Oh, okay.
And it also means that, you know.
Okay, so we have a thing which goes. We have an arm which comes out from, which moves up and down. Plus, we have another block on top which holds the lead screw.
That's right.
Right. Okay. Engineering quite a few things now.
This is like a day, maybe 2 days, CAD work, and then a prototype.
Okay.
It's not a lot.
Yeah. And but these are all machined. None of this would be cast, right? It'd be all.
You could cast everything.
Casting's more, right?
You could machine everything, but you could also probably cast it all, because you just do a finishing operation on the bearing mount, and that's about it.
Right.
And the plastic insert you would need to machine. Oh, and you obviously can't have that linear guide way.
Yeah.
Linear rail, guide way. Guide. They're different. It's a rail.
I do like the idea of just buying the camera from, because that's where the magic's in the camera.
Is great.
The magic's in the camera,
Yeah.
right? And we're not going to engineer. Oh, I tell you what, having that top block, you could put a cable holder on there because the HDMI cable has to come out of here and the USB cable to power.
Oh, and it's always in the way.
And it's always in the way.
Yeah, and you can bring it down,
Yep.
actually. You can get hollow... Those linear rails, they
Right.
come in hollow variants. Your cable can go straight through it. But that requires you to have the cables made after.
Yeah, no. The cables can come flapping out and the breeze out the back. But as long as they're anchored on top so that the stress is being taken here and it's not being taken in these two connectors.
Yeah.
Right?
Yeah, in fact, have a U-loop, a loop.
Yeah,
So
a little. Yeah. Oh, it's got to come. Oh, right.
But it'll be okay. It'll be okay. It'll be like this.
HDMI cables, though, are you can get.
That's not HDMI cable.
No, you can get really tiny, thin, flexible HDMI cables, but they're specialised.
Yeah.
They're specialised. Most HDMI, I've got HDMI cables here. Nothing ever goes back in the same spot. You'll say display cables. Displays.
Yeah, I saw that. Oh, there.
Display cables. There we go. Alright, and it's like, look, there's one, right, and that's like stiff as.
Is this a full-size HDMI?
Yeah. Oh, sorry, no, it's a mini. It's a mini, HDMI mini.
Okay, so this is kind of what the loopy would be, because it's 15 centimeters now.
Yeah, but then it's got to come in an angle like this, right? And there's a lot of stress. It's just not going to work.
Well, it can loop back to here, I guess.
Anyway, that's an issue which does not impact the rest of the design.
No.
No,
not substantially.
I don't think it impacts it at all, unless you wanted to integrate it, which I don't think we need to. So.
Yeah, so it's like, I don't know, it's up to you which...
Now, I was on a thought there for a second. That begs the question. This needs power.
Mm-hmm.
We have power.
Oh. This type of thing.
I'm thinking.
Could this power your USB? Your light? These type of battery packs?
Yeah.
Because battery packs are great. And
that's what I'm thinking.
The energy density keeps increasing.
I know. And it's rechargeable. The whole thing, you can move it anywhere.
Yeah.
So.
And it's power. And if you do integrate that type of functionality, everything's powerable through USB.
Exactly. So, this power pack can power our microscope. Plus, do these things work when you plug in power into them? Like, can you be charging it and powering something at the same time? I don't think I've ever tried that.
I'm willing to explode it. Let's do it.
There's probably under the bottom might be a
9.
Do
Do you have another battery pack?
There we go.
We can plug it into a separate battery pack. Oh, it's just a Zeus.
Zeus.
These ones are really good chargers.
Yep.
What the hell?
Yeah, they're dicky
a
power
plug.
boards. Yeah, Dodgy Brothers power board.
I'm confused. What's going on? Ah, it's stuck in my head.
Okay.
I need this one. Alright.
Yeah, there we go. Yep. That'll do the business.
There we go.
Does it tell you it's charging and powering at the same time? What is it?
I don't know.
Welcome.
Oh, it's not blowing up.
No.
Getting warm? No. But
It's good, isn't it? That's as far as you wouldn't want to go any lower than that. I don't necessarily think you would.
I've been thinking about that thing, you know when you unfocus it?
Yeah.
So, you know how we see colours in, I think it's a logarithmic scale? Or is it another scale? It's not linear.
It's not entirely linear, but
Or
it's not logarithmic.
Square, maybe. I don't know. But see how when it blurs, it looks
Yeah.
darker?
Yes.
Like in reality, it's not.
Yeah.
That's just our
Yeah.
colour scale, right?
Yeah.
Yeah, that's really interesting.
Oh.
It
Right,
gets
it's
darker.
nothing to do with the design. Okay.
No.
Anyway, that is, by the way, at full thing, it's 12 millimeters, 12 and a half.
Yeah.
12 and a half by, here's the thing.
Oh, it's flashing. Does that mean it's charging? Well, it was running through the...
It was running through that. So it
Well, just shut it down.
Right. It
Like turn it-
wasn't coming. Oh no, it's back on.
Yeah, I just turned it back on.
Oh right.
And if I do this, it starts flashing.
So it is charging.
Yeah.
Right. So I think we should design it so that one of these just sits on there, or you have to connect it in, or hold it in place somehow. But that powers, rather than have two cables coming out. Well, it just makes it portable.
Yeah.
But do people need portable? And then you've got to go buy a power pack. Well, you don't have to. You don't have to buy it. That's the thing. You don't have to buy it.
Yeah.
You just plug it straight in.
Plug it straight
But
in.
then, what about the weight? Right? The reason that we're putting that on the back is batteries on the back is to
These are still. Oh, if you don't buy it, right? Of course.
tell people, tape something on the back. Doesn't matter what. Or you can even provide a block of
Ballast.
suitable ballast. You can even provide ballast. It was suitable. Adds to the shipping cost, but
It will have a little bit out, so the support will be a bit more.
right.
We can actually emulate what it would be with your rulers by taping it on
Oh no.
by the distance out.
No, I just
You can figure out how
we
much
just-
you need.
I would not go past 15 cent. Would not go past 15 mil.
Okay, that's 15 mil.
Yep.
Let's try that. Tape it on, and then that'll provide you the
yeah.
same amount of support you'll have,
Well,
apart from the weight.
no. Apart from the fact that these are flexible as anything.
Yeah.
No,
But
no.
There's not a lot of it going into there. Most of the force is at the back, front.
True.
Right here, actually.
True. Oh, here we go.
Oh yeah.
No. We got nice aluminium shafts.
I'm using these flexi rulers. There you go.
And stick it out by. We can decide on a value now. Stick it out by 15. I reckon anything more than 15.
How's that?
Well, actually, that's not past the centre, right? What we're doing is from the centre. Yeah. Got to have that reference point. 25.
Okay, there you go.
Let's say 25 is our reference point.
We technically only need to tape at the back, so.
I'll just eyeball that. Yeah. Yeah. Good enough for Australia. All right.
I mean, because ideally, ballast would be irrelevant, right?
Yes. Oh, geez, I was a millimetre off on the eyeball in there. Oh, I'm disappointed in myself. Hang on.
Working in Imperial.
Yeah. Bloody micro ruler. Okay, now, hang on. Now I'm 30. Now I'm 30 millimetres out. Hang on. There we go. Oh, bloody hell. Can you...
Yeah.
Hold that. Right, thank you. $25. $25.
Okay. And that's that. That's the amount of. Oh man, that's heaps good. Try that.
That is
That's-
no problem whatsoever. That's all it needed.
Well, not when we put it out further.
Oh, well, okay. No.
That was a hit. That was quite a big.
Oh, but no, but this weight's going to come out further.
Yes. It's a lot better. A lot better.
I agree. Yeah, it doesn't have to come out far.
And it
From that
It
centre
can
point.
come out far over here. So you're 25 here.
Yes.
But it can come out 30 over here.
It can.
And it's effectively the same. It's actually better
But
in
the
every...
problem is, assuming your reference thing, your reference object is an A4 size piece of paper, it doesn't matter how far it comes out here, it's going to hit
It's true.
the board.
It's true.
So, there ain't no free lunch there, I'm afraid.
It's free for boards smaller than A4.
A5.
Yeah.
A5 is our reference. I'm a bit of an A5 fanboy now.
Me too.
Yep.
Me too. My eyes are okay. That works really well.
Yeah. Yep. Oh my god, now we're talking about custom everything. All right, a lead screw.
But that custom mechanical is far less risky than custom electric. It's just more time consuming in terms of manufacturing. Like, you have to set up the people. But I've already got people to do aluminium stuff like this.
Yep. Cool. Yeah, all right. Well, I think we should have a shot. It's worth having a shot, and if it turns out to be, you won't know until you get it in your hands and play with it.
So do you want full assembly, base?
Yep. Why not?
Or
yeah, let's try it. We can always go back to this.
Yep. Okay.
What's the worst?
So what do you want the base shape? Starship.
I reckon it's got to be something funky.
The Daedalus.
I don't know. We're going to have to. That requires some thought. Yeah. That requires some thought. But yeah, I think it needs to be something that's Sagan toy. Mm-hmm. Yep. Part of. Yeah.
So this is the lights now.
Yeah, the lights. The lights are sort of a science in themselves, choosing the ones with the right angle, how far you're going to space them. I thought about having a switch on top so that you can like turn on quadrants.
Yeah. Or
something. So like if you only wanted it coming from this side, you could like by default they're all on, but you could actually cycle maybe a single button cycle through.
Is that a microcontroller based system?
Yeah, it'd be a micro or something.
Yeah.
I'm
always looking for a micro with like high source capability.
Right. Although ideally, right? No, I'm not driving it directly. No. Because it'll be a switch mode to drive the LED, so it'll be a LED switch mode controller.
Oh right, of course, constant current.
Yeah.
Yeah, because otherwise it'd be variation.
It'd be a constant current driver. But the problem is you want to avoid micros if possible. If there's a solution that you don't have to cycle through modes, but you can do that without a micro. You can do that in discrete logic. You just got to be a bit clever about it.
Just a counter.
Anyway, these, see, the problem is to have a really good ring light is going to require some power, right?
These can deliver 2.1.
Yeah. It's going to require significant, but this, I'm going to have to measure the power consumption of this, so we won't do that now.
Yeah.
But, I mean, once again, the battery solution is separate from the other separate from the other design stuff. Yeah. So you can design everything else and then change your battery solution later.
The battery thing can be an addition as well. So
yes.
You can have that ring light battery system.
Yeah. Oh yeah. If
can be the same regardless.
Right. Yes.
Yep. Like having counterweight is never bad. Especially
exactly.
if this isn't here.
Yeah, totally.
It's actually better with the new thing.
Well, that's what you do. I mean, no, I think we need a battery solution. I would not like to release this and go, plug in a plug pack. Like, it's just another lead coming out.
Good.
Like, batteries are good.
Yeah.
And realistically, a lot of people are using this just to do a bit of rework. You know, or something like that. Sure, if you're soldering an entire board and you're going to be spending 8 hours doing it, okay, well, you plug in the external plug pack, right? Or if the batteries last 8 hours, fine.
Yeah.
But,
My brain just went through that thing where it's like the gilding the lily thing.
Yeah, what?
When it detects movement, it can brighten.
Shit.
Double our battery life.
Shit.
You easily would.
I actually like that.
So do I. I hate it though.
Like that.
I hate that I like it.
Yeah. Yeah.
Sorry.
Yeah. How would you do that?
Well, it is an emitter, so you can look for reflection.
Oh, if you got you can get an emitter, yeah, but cameras are sensitive to IR.
Oh, that was dumb of me. That's true. It is a camera.
It is a camera. You can't do it. Ultrasonics.
Infrared reflection. Any change in value within threshold?
No. Let's just tap into the video output and detect the motion. Like that's how it.
That is good, but it could be difficult.
Yeah, no. That's just getting silly. No, manually do it. No, I keep saying no, internet connected light bulbs and smart light bulbs. Bullshit. Just flick a freaking switch off and on or have a knob. If you want to dim it, have a freaking dimmer knob on the side of the... Yeah, none of this clapping shit. No. None
Every
of this
time-
smartphone control.
Every time you
know.
put your phone down, the lights turn off. You're like, damn it.
Oh,
Yeah.
no.
Okay, so no.
So,
All right. So
we need a funky shape for the base.
Yeah.
You're working a shaft and a lead screw. Oh, and then we've got to design our own. Everything, right? So the only thing you need to know is the diameter of this thing.
which
right?
is really good.
I know, yeah, right.
Because it means like I'm okay. I'm good. Good to go.
Yep.
There's no
Yep.
measuring needed. I can
No.
do it remotely.
We can get the calipers out now, and that's it. Would you want a third one? Are
Oh,
you a
that's-
fanboy of 3? Grub screws hold something like that in, or 2? I always thought 2 was a bit dicky.
I've got a better way.
Oh,
Do
God,
it with
yeah.
one, and do a ring clamp. You can do it with one piece.
You can get a ring.
and it's
I got
better
some
in,
of those here.
It's better in all ways. You can actually
Yeah.
incorporate it into the assembly really easily. I did it with all my CNC stuff.
You wouldn't even need to do that. You get a ring clamp, and the ring goes through a slot in the...
Yeah, if I could draw it.
Yeah.
Oh, I hate
Oh,
things.
yeah, this place is a mess.
Have you ever permanent marked live video?
Permanent market. Yes, I have. I have permanent market on my whiteboard.
Should I move over there?
Yeah?
Yeah.
You have to tilt up, though,
Oh, terrible, aren't I?
unless you want to do down.
I don't know what I'm doing. Oh, I'll do down. I'm trying to get you in the video. Yep, you're still
No,
in.
I don't know. I'm still in.
Yep.
In like Flynn.
Yep, so
I think that's going to be out of the shot.
it definitely is.
Is that...
Oh, that's in shot. That's in shot.
Right.
So we can put a ring clamp like this.
Yeah, you're right. That is in shot.
And then on the outside, then you make a break. This is a simple version. You'd almost always
Hang
have
on.
this at an angle. And then you have the bolt recess in here,
Hang on. Where's the ring clamps?
and then thread here.
Whoa, whoa, whoa. Hang on. I'm not...
Camera.
Yep.
This is aluminium.
Yep.
You tighten that.
What's the
flex-
distance between the aluminium and the... Oh, you're talking about... Oh, right. The
These are-
aluminium becomes a ring clamp.
Yeah, and
And you'd only have to have maybe a 0.5 millimeter...
yeah, they're really good. And this is actually not a practical version. The practical version has this at an angle.
Yeah, I've seen those and used those. Yeah, it's right. It's probably...
They're
Is
superbly
that
nice.
diameter, is that enough to get... Because the
Yeah,
smaller you make
easily.
it, the harder it is.
Yeah, no, see, that's easy. I
Yeah,
did
big,
it. I
or
did
like
it.
because a big one is easier to close a millimeter, but
Yeah.
a smaller one is to close a millimeter.
Yeah.
So, right.
And here's the better part.
Yep, I like that.
This never jams.
Yep, yep.
You can always undo
Yep.
it, and you can put the thing at the front
Yep.
where it's always out of the way,
Oh, you would put the screw in the front.
or anywhere. You can put it anywhere you want.
I would put it in the front because it's got to go extend out the back.
Yeah.
So it's all one piece. It's all one
Yeah,
die-cast piece.
Yeah, it's not even. Yeah.
Yep. Winner. Winner.
Yep.
Winner. Done. Sold.
Sweet.
Yep. Nice work. Yep.
I have this urge to knock over cylinders. It's weird.
I can picture you being one of those cup stackers.
I have the urge when I see cups.
What happened to that? It was like some sort of they wanted it as an Olympic sport or some crap.
It's pretty cool.
Cup stacking. And then it's just I never heard about it again.
I can kind of do it, but I have to. I've stopped myself every time. 'Cause
Right,
it's like,
you're not fluid.
Yeah.
You're not fluid enough. You're not.
I can do the brr, 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 and I
Right.
can stack it, but then I always knock it over when I'm not concentrating. So I'm like grabbing a cup, like, oh shit, what am I doing? I don't know.
All right. All right. Yeah, right. So we went from let's just do a PCB and a new base to let's design everything.
Except this,
Yay.
I'd never want to design that part. The optics,
No. The
I'm
optics are special.
so left far field.
Yeah.
Um,
I wonder. I wonder if they've actually got optics experts there that actually figured it all out and ordered the right lens, or whether or not they just. By the looks of the hot melt glue in there, I think they just let's order 20 different lenses from 20 manufacturers and see which one works. And I think they got one. I think that's how they designed it.
Yeah, probably.
Which is no, like, and there's nothing wrong with that. You know, there's, like, you know, the end result is what matters.
It's not even necessarily
it's
slower.
the Edison method. So
Yeah.
Thomas, like, he was.
Was he an empirical, like, super empirical guy?
Yeah, he did not know how to do any theory at all.
didn't know that.
He was like, yeah, his lab was the best in the world. He had every chemical element in every jar, and he literally tried things 1,000 times until he found the thing that works, patented. Like,
Wow.
he was, I've got not an autobiography, but a biography of Thomas Edison. That's how he worked. That was his thing.
I wonder how much poisonous gas he made.
So there's a lot of people out there, including contemporaries at the time, his
Yeah.
colleagues at the time, who did not think highly of him because he couldn't do the theory.
Yeah.
He just brute forced everything.
Yeah, but
And,
his
you know,
his achievements are obvious.
his achievements are obvious, right?
Yeah.
He achieved the result by doing things 1,000 times and 900, and it's the old adage, Edison figured out, he tried it 1,000 times until he got the light bulb that he wanted. They gave a long life.
That's
And
way more amazing than just going nup, because that would have taken ages.
I know. Oh, he had assistants and everything,
Still.
Yeah, I know. But yeah, his lab just literally had everything, and he just tried every, he didn't understand why. He didn't know that, there's no way in hell that could work.
Yeah.
Because of the chemistry. It just can't work. But he tried it anyway.
Didn't matter.
It didn't matter.
Yeah.
It's just time. So, there you go. So,
Unlike his rival.
right.
Tesla knew what was going on, right?
Oh, yeah. Tesla, yes.
He knew the score.
Yes, he knew the math.
Yeah.
Yep. Tesla is in those books there, by the way.
Really?
Yes. Some of those from 1914. They reference, is this the 1914 one?
I'm so glad about the Tesla car company bringing back the name of Tesla
Right.
from the like.
So you're
Voodoo
a
science?
Tesla. No, this is 1942. No, we need the original one, which is.
Like the free energy nutters.
Oh, yeah,
Love
yeah.
Tesla, right?
Oh yeah, no, they.
But
worship
I'm so glad Tesla, the car company, has like
Right.
taken that name away.
Oh right, so that yeah.
Now it's legit again.
Yeah.
It's like,
Authors and this is like the reference work, 1924, and I think I don't think they're alphabetical order. But, anyway, you might find him in here. So there you go. Authorities consulted. I think was he still alive then? When did Tesla die?
what year's that?
This is 1924, but it probably originally predates that.
Resuming.
Nikola Tesla. There you go.
Oh.
Inventor of original induction motor and numerous other electrical appliances, fellow American Institute of Electrical Engineers, author of experiments with alternate currents of high potential and high frequency. There you go.
He died in 1943.
Google.
Yep.
There you go. Wow, that's pretty recent.
Yeah.
There you go. Anyway, he was consulted and
He went through the war a little bit.
Yeah.
Never thought.
He didn't live to see the bomb though.
No.
All right, so that's done and dusted for the brainstorming session of
Cool.
this thing, is it?
Should we combine the footage with the microcurrent project?
No,
Um,
it's separate. It's separate. So that's it.
I mean, did you want to do a split take? So
Oh.
bye, and then
Bye.
just continue.
We're doing several projects, so yep, that's a bye. No, don't sit. No, that's just go back. No, I'll take that back, please. All right. So yeah, bye.
Great.